is typically not a pure fluid thing, because when you think as a wave on a water wave in the ocean, you will have all sorts of effects from gravity, wind, earth rotation, atomic drag, down to minimalistic influences of quantum effects on the hydrogen and the water molecule and H2O. So there are coming so many things together that it looks random when you look from a close to not too far distance. When you go very far away, then the surface is an average height of the water molecules, and you don't see that they are atomic anymore. And water, when you have a nice impact speed, can be as hard as concrete, and is, because it's not compressible. Now, when you think why actually water is not compressible, raises the question, the electric effects should, from a magnetic point of view, be compressible, because the magnetic force fields you can actually quite easy press together, but the force is getting higher and higher. What we don't know is that the water molecules in what we perceive as a fluid, while our brain knows from the books it's all discrete, there is nothing fluid. Yeah? This is an illusion which makes it nice to drink when you're thirsty and to swim when you're overheated, to get cooled down, but this is all psychological. We have never to forget that everything already in the books, so by the theories we try to improve, is quantized. A molecule is a complex thing in a sense. Even a HO2 molecule has a lot of rotational freedom degrees. So it is not a static thing like a brick of Lego. It has axes where it can rotate in several degrees of freedoms, but not arbitrary degrees of freedoms. And all these mixed together make it, for a reason I never fully understood, incompressible.
Yeah, well, why is it?
Then you have a medium where you say you have Bernoulli effects by gravitation, then is immediately the question from my side, is it also not compressible, or is it bendable, like in Einstein's theory of relativity, to have the analogy of this bendable thing? I read a few good books about relativity, hopefully, and they all tell me that everything you see in video and YouTube videos on the typical experiments where these typical steel ball is in a rubber. This is complete bullshit. Okay, this is the wrong visualization of it in nearly all aspects. It is falsely wrong because it's not deep enough. It is wrong because a mass is pulling a stretched fiber down, which is also not the curves are wrong. So I had in these introductory books good reasons to believe them, that nearly all of that is just a nice mind picture to show how it feels to bend a space direction. And of course, you cannot show more than one at a time. You would only make that a one-dimensional analogy, that you bend a line down. That would be even a better analogy than showing the two-dimensional stuff bent, because that is just not the case. Neither force-wise nor otherwise. It's just wrong. And wrong models often look good, but they are not the right way to approach Lego, because when you approach Lego, you suddenly have to deal with 40-digit numbers, and now we need it exact. And how do you compare the need for exactness in iSpace with a bendable thing? This is why I never thought it fits well together. And that is what the theorists of the last 100 years also told us, namely that compatibility of theory of relativity as we know it is just not given with quantum mechanical parts we know. And from what I have recognized over the ResearchGates documents over the last years, the experimental results go in the direction that cosmology is wrong. When cosmology is wrong, relativity is wrong, and quantum mechanics is not wrong. Otherwise, our iPhones wouldn't work so well. So that is also an oversimplification, but it at least goes in the right direction. But when we think that quantum mechanics is not wrong, and quantum mechanics is all about electromagnetic forces, basically, and from there on, I try to make bridges to how could an electromagnetic force be weaker than the electrostatic force exactly in that amount, which would be needed to be gravity. And it happens that iSpace theory showed us a simple solution, really simple solution. The square of the speed in iSpace divided by the speed of light in SI space, multiplied with the square of the iSpace spacetime in SI divided by the square of the iSpace spacetime in iSpace IQ units. And both units are self-consistent. Both units give the same SI results. Both units are Lego. Both units are exact. And the value we get from that equation is 10 to the power of 42 about. 2 times 10 to the power of 42 is exactly the range of given gravitational strength to electrostatic range weakness. And John R. Marken, in his very, very good but not well recognized book, had predicted that the strength of the gravitational force as a ratio to the electrostatic force is the electrostatic force ratio to the Planck force, which gives the simple equation that the strength of the gravitational force is the electrostatic force squared over the Planck force. And when you have that simple equation, look on iSpace value, what results is, and you get basically this 3 divided by 299792458 to the power of 4 times a decadic factor, which is explainable by other things. And this results in about 3 to the power of minus 46 Newton, and is exactly right because it's also the Planck force times alpha g squared, as I showed last meeting quickly in the why you shouldn't invent values to predict g when you only have measurement input of 4 digits, because you can predict an elephant out of an Easter bunny and everything looks correct but is meaningless. But such an equation like alpha g squared times Planck force is a gravitational force and gives the same result than the other theory from iSpace, which comes from the Lego side, is never coincidental. And Lego is not compressible as long as you don't make the Lego bricks out of rubber. But I'm not saying they might be in rubber form, and then it would be also bendable. So when we have Lego pieces under normal constraints, so with weak gravity situations, they might very well be completely squeezed together because that doesn't inviolate any rules of movement in iSpace. So in iSpace, you have no continuum. Yeah, that's the main thing. So when you want to go from position A to B, you need to jump. You jump from Lego to Lego, coordinates, whatever. It's like more a computer game or a simulation than a typical classical view of what a relativity and most parts of quantum mechanics from equation point of view would show. But the quantum mechanic equations at least know they are quantized one way or another, even if they don't like to give in. Yeah? But they are.
Okay, yeah. I was wondering, so you're saying the electrostatic force and then is it the dissimilarity between the static charge or the electrostatic charge and the electromagnetic force is gravity or something? Was that what you said, or was it
no? From a pure force. So when first of all, relativity says there is no force, and that is wrong. When we assume there is a force, not just a felt simulated force by bending something, but a true force. Like nobody would justify that the electromagnetic force of 2 toy magnets in a children's train is not a real force. It is a force field. It's super easy to visualize by iron powder. So this is a real thing. Everybody has access to this kind of logic, and nobody is really thinking that would be some magic bendings of anything until the iron particles came to rest in the make nice force lines. So the force is just that, is a force field. And every electron in the magnet is a singular point of emission of a field line bending to the other magnet or closing a loop in its own. Field lines are never open. In monopoles, I'm not sure. That may be a completely different thing. But in a normal world, they are not open. They're closed. And have to be. Also by the curl equation.
But yeah, so we say, but you're not or are you suggesting that somehow there's this discrepancy between the electrostatic field and electromagnetism?
I wasn't complete. So what I'm saying is just what John R. Marken has prepared in his book as primary result of his equations, that everything is a fluid quantum vacuum with waves. This is not my model, but his model is extremely compatible to my model when you see what the results are. When you have two continuous waves overlapping in a certain circular way and rotating, then you get particle-like structures, fully automatic. You get vortices and stuff like that. And the force he calculated for that, for purely theoretical reasoning from the force field equations of these wave equations, which are continuous, by the way,
Right.
he concluded that Fg over Fe is Fe over F Planck. And I, with iSpace theory, had easy to calculate the Fg. No, because Fg is c to the power over g, yeah, when you calculate it as Planck force. Okay? That's from the books, but then you have g on the left side, g on the right side, and you get 1 equals 1, and you know nothing. But in iSpace, I had, due to the way I calculated g without knowing g from quantum values, I had an independent value for g. So I could solve the equation and show what the electrostatic force is. And the distance where that becomes relevant is exactly the mid-range between the Bohr radius and the classical electron radius. The Bohr radius is 10 to the power of minus 15, about 5 somethings 10 to the power of minus 15, and the classical 10 to the power of minus 12, and the classical electron radius is 10 to the power of minus 15. And when you multiply with alpha squared, fine structure constant squared, you come from the Bohr radius to the classical electron radius. And when you not multiply with alpha squared, but just with alpha, you end up in about 3 to the power of 3 times 10 to the power of minus 13 meters. And that is exactly the area where the iSpace theory predicts that things become discrete. So on the right side of that is everything Lego or Lego Duplo. On the left side is liquid or sand or whatever you molecule way of things. And for this, I'm absolutely sure. Now, what has that for force consequences? When I can calculate the Planck force independently and get a value which is 3 divided by c to the power of 4 numerically, basically. Yeah, so this is a 10 to the power of minus 46 Newton. And I can see where it comes from geometrically. And there is no integer geometry, and this is just a numerical value. So this is just the value 3 comes from the integer circle. A half of 2 times pi 3 times 1, so a half of 6 is 3. And divided by 299,792,458 to the power of 4 gives you the mantissa field. And then you need just a 10 to the power of 12 exponent correction. And when you know the values of alpha g, I have them here because I cannot remember them easily. I should be better in these things by now, but just let me look them up. So alpha g is 1.751759787 and so on to the power of minus 45 and is unitless. And when you square that, then you get 3.068662655 somethings and so on to the power of minus 90, obviously. And the Planck force in its own, you have that quantized in SI system is 1.2102 as is in the books, and the books don't have more digits because G is only measured with 5 digits. But my value goes on 8, 9, 5, 8, 1, 3, 2, and so on as I like it, to the power of 44 volt ampere second per meter or Newton. Yeah? And when you multiply alpha g squared with that value, I have Planck force, then you get 3.7139 to the power of minus 46 volt ampere second per meter. This is Newton. But when you look at the geometrical result in iSpace of that, when I take the numerical value away, then it's the number 3 volt ampere second divided by 8076087713 and so on, blah, 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 a long integer number. And when you take the fourth root of that integer number, you just get 299792458,000. And that is certainly no accident. That is for one, the speed of light in SI system, but it is also when you divide it by 10 to the power of 7, the Planck resistance in SI system, which most people overlook. And in the case of the initial demonstration I gave, I already showed why that is not the speed of light here, but the Planck resistance. And that makes sense because the Planck resistance is the biggest force field you can have as a resistance field where a wave can be bound electrically. A Planck resistance is an electric resistance. I mean, get it, yeah? And that's why I have written the paper together with Emmanouil on that, which he immediately, with his better physical insight than me, didn't only saw the value, which was compatible with his theory, but he saw the reason why it is compatible, because he sees this horn tube electron, and it makes sense physically, and I see the Lego parts giving exact values, and both is exact fully compatible because the fine structure constant, everything cancels out in this equation. But what his theory didn't give is he only saw the quantum values, and I could see the cosmological thing of it. And when you combine both, you have the exact same value of this force from a cosmological value and from a quantum value, which makes them the identical force. And when we know where we came from a ratio of the electrostatic force squared to the Planck force. Now, what shall I think of gravity? That is also an electric force, of course, because the equations with which I started didn't contain anything other than gravity. I didn't start with G. I start with forces.
Well, that's kind of what I was getting at. I was trying to ask, so does that mean that gravity would be an electrostatic force or electric?
I'm not saying electrostatic. This is too simple. It is electromagnetism consists of an electric field and a magnetic field which cannot live with each other, without each other, and is 90-degree phase shifted. That is all we know for sure. But would you have a 6-dimensional subspace, you would swing between electromagnetism and magnetoelectrism. So this is, I was always in the idea that there is no electromagnetic field, but a magnetomagnetic field, which means that you have a magnetic force, which is on the right side of a volume, and it swings over like a Zend clock to the left side of a volume and swings forth and back with this 90-degree phase shift. So it's the same thing. So when it's on the right side, it's electric. When it's on the left side, it's also electric, but the other side does the same with the phase change. So electric and magnetic forces are exactly the same physical thing. They just, when they're in subspace left, they are magnetic, and when they're in subspace right, they are electric. And that explains everything. Then you have time, then you have 7 dimension, and out of these Calabi-Yau entities of pixels, which are infinitely thin, because a Calabi-Yau mathematically has no outside, not just inside. This is difficult to understand unless you think a little psychologically and philosophically about what a Calabi-Yau not actually is. You bend the left to the right of a cube, you bend the top to the bottom of a cube, then you have already an analog torus, like the structure of the electron, which is round, has a donut hole, which is round. There's nothing square anymore when you do that. When you make it out of foam, you can bend it and glue it together. And then you see a hole of unit radius 1 and a diameter of golden ratio of that torus. That is exactly the image of Emmanouil in the common paper which we had. And which he published before.
Does that depend on the size of the cube that you start with? Does it have to be like...
No, you have to calibrate that in his I system. This is the cool thing. I cannot escape. This is golden ratio and 1 in ampere units. So this is why iSpace theory is saying we have golden ratio ampere as a ratio to 1 ampere. And that actually is the diameter of the horn tube inside to outside ratio.
Right, but that's different to Manuel's work where...
No, it's not. It's not. It's just differently scaled in the graphics. This is exactly what Emmanouil is doing. What Emmanouil can predict.
Oh, maybe you're right. Yeah. Doesn't Emmanouil have the is it alpha? The fine structure constant is the gap in the center.
The diameter ratio of the horn tube inner to the outer diameter of the magnetic shell of his model, and that is absolutely correct.
Oh, right. So if you were to do the same thing with this other torus you're talking about, you get this.
And his model can predict something iSpace cannot, namely why there is a G-2 ratio, which is not exactly 2. Because in the horn torus, you get a different symmetry break of the torus outside, which is stable in the sense of uncompressible, the part of the electron which doesn't bend, and the horn torus top-bottom side, which is a little bit smaller because of the inlets of the horn torus flow-through.
Yeah.
And that is not exactly 2. The ratio is a little bit less, and that is what makes the electron G factor its strange value offset of 2. But as the value is very precise...
You're not talking about the muon G factor there.
The muons are just electrons with more mass, so you get a different shape of the horn torus and have a different G value for that. It's just because the geometry is changing.
Well, I mean, does he have a model of the muon?
No, but he has a qualitative explanation due to that. iSpace would not be able to explain an offset of 2 because I say all my Legos are 1, 1, 1. Why should they bend and be suddenly 1.0011 something? Yeah, this makes no sense. But in a continuous model, it makes much sense. Exactly that.
Yeah, so, but if you're able to bend the cubes into toruses, then it doesn't. Surely, then you don't have that problem.
Now you got me, because when you bend space-time itself, with itself, it sort of dissects itself from continuum. Should there be one? Think of it. You will start with a raster which is 3-dimensional. And on that raster of 3-dimensional coordinates, which are perfectly Euclidean and perfectly non-relativistic and perfectly Newtonian.
Yeah.
You put on every grid a Rubik's Cube.
All right.
The Rubik's Cube has the weight of 1 kilogram, say just a number, or the weight of 1 electron. It doesn't matter. So just start with a mass. Yeah.
Sure. Yeah.
So, and that mass would be the vacuum, which is not accepted by classical theories of relativity, but this is what I'm saying is there. You have,
okay.
In the vacuum, there is something. Yeah.
Sure. Yeah, I agree.
A field or whatever you name it, it is not nothing. It's not vacuum, emptiness. It is a force field with its own, but the forces are all balanced. And now we do the geometric trick. Take all the Rubik's Cubes you have there, which would be visible. Well, you could look with a telescope in the sky. When you look precise enough, you would see a lot of Rubik's Cubes. Say, Christian, yeah, I found the Rubik's Cube. You're right. So, but we have looked very, very precise. There are no Rubik's Cubes when we look with a telescope. We look into the effective emptiness unless there is a gravity and has created a star, which is illuminating something to see. And why that is easy to explain from a logical model. In iSpace, you have this 10 dimension, and 6 are rolled in Calabi-Yau space-time. And to do that, you take each individual Rubik's Cube, pull it to the right to a length which you want, like a rubber band, which can be very, very long pulled. Say a 1 meter rubber band can be pulled to 100 meters or something easily by not breaking the band. Yeah. Then you glue it together. Then you have a ring of already some inner force because you glued something together against its will in a direction where it normally would like to be a square Rubik's Cube, but it isn't anymore. So it has a force now in this. Energy has to be put to bend it. So this.
Yeah.
So then you bend the upside to the downside and you get a double torus. You have even more force to pull it in this direction because it is already distorted, and you distort it in the second direction.
Yeah, of course. You
do that willingly because you're in the master of simulation or whatever you do there. It's a thought experiment. And then you have a real torus, which you would X-ray the torus. You would see inside the torus is a tube which has diameter 1. And the torus itself is of diameter golden ratio at the was ist Wandstärke auf English? I don't know the thickness of the pricks. Yeah. Forming the torus is golden ratio, whereas you can choose what is the diameter of the whole of the torus and what is the diameter of the ring size of the torus, because this depends a little bit on how much energy did you bend in the tearing apart and gluing together. When you tear more, then you get a different diameter, different thing. So, but in the end, it will snap back and find a balance between its original 1-1-1 geometry and the torus geometry. And when that balance has been reached, we have created a subspace which is closed, is still a 3-dimensional object. So now we have just done the following. We bend X and Y coordinates in a way that our Rubik's Cubes, all of them trillions, are now not Rubik's Cubes anymore, but they are still exactly the same mass of the Rubik's Cubes, the same color of the Rubik's Cubes. Nothing has changed, but they are now donuts with a hole in it, where it could be marmalade in or whatever. Yeah, like to say that. And then we do the final step, because God has told, please don't skip the Z direction. He said, I don't prefer the X direction, the Y direction. If you bend the torus in X and Y direction, Would you please then also do the same in the Z direction? And then comes my little 10-degree math child and says, dear Mr. Teacher of Physics, in 3 dimensions, we cannot bend the inside of a torus to the outside. And then the math teacher has had an exam in quantum mechanics and said, yes, you're right, but only in 3 dimensions. In 6 dimensions, it's easy to bend the inside to the outside. And you don't understand it yet because you have not studied 6-dimensional space-time yet. And no. would you have
space-time? So you're really talking about 5-dimensional spatial.
A 5-dimension would be enough, but once again, God doesn't like asymmetries. It doesn't prefer the x-axis. So for the x-axis, I have an anti-x-axis. For the y-axis, I have an anti-y-axis. And for the z-axis, I have an anti-z-axis. Makes 6 dimensions. And I can easily glue the x to the anti-x, the y to the anti-y, and z to the anti-z. Everything is fully symmetric. But what do you end up with when you do the final glue? You glue now the inside of something 3-dimensional, where the marmalade is, to the outside, where the space is still the distance between one cube to the next cube, okay? And if you do that mentally, and there is no marmalade, then the thing will disappear in front of your eyes, because you bend now the outside to the inside, and that makes an object, which is a Calabi-Yau space, technically, and that has no outside anymore. It has just inside. So when you live in that cube, you recognize that exactly the same things you could do in the cube than before. Walk to the left, walk to the right, up, down, forth, back. You can still fully do, because you're bended, but the cube isn't gone. Your distance is inside the cube where Lego, and that has not changed. That has not changed. So the mechanics of iSpace, of quantum mechanics, doesn't change a bit, because you jump from colored Rubik's Cube step to next colored Rubik's Cube step. And if you bend that or not, doesn't make a step distance jump different. It's still the exact same number of jumps than before. Hence, when you are a flatlander or a 3-dimensional flatlander inside the Rubik's Cube of 3 dimensions, which we are, you don't recognize that you are bent to hell.
Right, but you know, like I mean, I'm trying to visualize it here with this torus and the inside and the outside, and you know, just in maybe 4 dimensions. So does that mean you need to start with a 4-dimensional cube, or do you start with a 3?
No, you start with a 6-dimensional subspace plus time is 7 dimensions.
No, I'm just saying, like, if I was, I'm following the same logic just in 4 dimensions. Do I start with
you
a 4-dimensional?
Because then you would.
I'm just like I'm tempting to do it in different dimensions. So if I start in 4 dimensions, I need a 3-dimensional cube, right? Or in 6 dimensions or whatever, right? So 3 dimensions. So yeah, when you try and do it in 4 dimensions, it obviously doesn't work. So what is the insight that allows you to understand that it's possible in 5 or 6?
No, it has nothing to do with 5 or 6 dimensions. For symmetry reason, I say make the 6 dimensions, then it's easy to understand.
Because you don't need 3 dimensions into 6.
Yeah. That is my subspace. And you have still the 3 dimensions have nothing to do. This is space, what we perceive. We are here on a computer screen, which is a 3-dimensional entity on planet Earth. And that is an object which has nothing to do with theory of relativity or nothing to do with theory of iSpace. It has to do with Newtonian theory. We have 3-dimensional objects here on our tables. Okay?
Sure.
But they are made of atoms. And what I'm saying is the atoms are made of space-time. And the space-time is made of
in the last half an hour or so. Might as well let him speak. What were you on, Rajan?
Yeah. So one of the things here is that the 3 dimensions we talk about, is it because of the symmetry, some sort of symmetry that makes it into 6 dimensions? Okay, so that let's hold on to that. So let me come back to the Bernoulli. I was not recording before, but the Bernoulli thing that I was talking about. So the Bernoulli up is the aircraft that's lifting up. That's anti-gravity or levitation. The Bernoulli down, which is created by the space, kind of a bending, like what Einstein is showing, is bending and producing the Bernoulli effect. If there's a sphere underneath, it's bending the space and creating like a hyperbolic space that creates that Bernoulli effect. But that Bernoulli effect is a mechanical equivalent. We convert to electromagnetism. So if we convert to electromagnetism, what is happening is that the magnetic effect, you see electric and magnetic effect, the same, we convert to equivalent electric magnetic effect, because finally the atoms are electromagnetic, atoms are the waves, right? So what is happening is that the magnetic thing, so this one is bending it, and the magnetic can, there is a loop, like you said, there may be a loop, a magnetic loop that's creating underneath, that creates like an attraction force. So that is pulling it down, and eventually, like we said, one of the things like what Christopher was.
Wait a second. You're talking about this Bernoulli effect, yeah? I'm not familiar with the Bernoulli effect. Well, what's pulling it? You're talking about an aircraft going up. What's pulling it down?
Oh, that's. May I have an easy answer for that? The flow.
Oh wait, I'm asking Rajan. No, he's got to field his own questions, and then you can chime in with your answer. But so, because I understand that, the wing of the plane is curved, so the air takes longer to go over, and there's vortices which reduce the pressure, and then so the pressure is pushing it up. So I mean, obviously there's still gravity there, but it's not having the same effect, right? So what are you talking about? Is it the gravity that's pulling it down? I mean, a plane goes up, it doesn't come down, right?
Yeah, the pressure effect. So it's essentially a pressure effect. What I'm saying is that mechanically, it's a pressure effect. The gravity essentially will be a pressure effect eventually. So
so you're saying that gravity is a push, not a pull, or or what? The
Bernoulli, let me explain the Bernoulli. The Bernoulli effect is based on the fact that it's a mechanical thing. Now we have to convert to electrical thing later on, but let's look at the mechanical aspect. So the mechanical aspect is that the pressure times the velocity is a constant. That's the basis for the Bernoulli. So if the air is moving fast, the velocity is higher, the pressure will be lower. So on top, you have the pressure lower. At the bottom, you have lower velocity, the pressure is higher, that pressure pushes the wing up. This is a very simple explanation of the Bernoulli effect, of how the aircraft gets the lift, because of the shape.
Right, so if the velocity is higher, the pressure is lower on the top.
Yeah. So that's the basis. That's the simplest concept that we can use. So now we convert for the gravity is the inverse aspect. What I'm saying is that instead of the top, it's the bottom. It's the bottom. Because now the curvature, like you said, the hypersphere, and you have shown that you can, clump it together and form positrons in the particle level and electrons when it goes up. So it's a concentration and a dilution effect. So concentration of mass. So that now we convert to electromagnetism, because same thing, the mechanical thing. Now we convert to electromagnetism because at the like Christian said, it's a positive and negative exactly match. So what is happening at that quantum level is that the magnetic and the electric effect eventually, I think, it's all magnetic. It's the movement of the magnetic thing, like in monopoles, that creates the electron thing. So I still think the fundamental thing is the magnetism, like monopoles, things like that. But when they move around, they start creating the electric field, and they have an interaction. They have what you call the feedback effect. So the electric, magnetic movement creates electric field, and the electric then creates the magnetic thing. So you have this complete, interaction. So in the Bernoulli thing, what is happening is that you have a compression of the magnetic field or the movement of the magnetic field in certain direction. Now we have to find the directions. It's in the orthogonal direction. So in the orthogonal direction, you have a magnetic effect, and that creates, like, it's always a dipole, right? So it creates a south and north pole, and that pulls it continuously. So the quantum level, quantum gravity level, you have this magnetic thing always creating that that effect, the Bernoulli thing, equivalent, equivalent effect. If you convert the Bernoulli effect mechanical thing into the electromagnetic thing, the magnetic dipole that forms keeps pulling it. So that's an attractive force, and then eventually there is a virtual center, like the center of Earth, for example. It creates because of the particular curvature that creates that high dense thing, and eventually we think that is the black hole. Black hole effect is a bigger aspect of this thing. If you visualize that, the center of the universe, things like that.
Yeah.
That's it.
Well, no, I'm a bit confused. I mean, you talk about the Bernoulli effect, velocity, pressure, and then you're saying the gravity is like the inverse of that. So just to paint that, gravity is the pressure. What's the velocity in this?
Yeah.
You're saying there's a comparison, is there? So what are the comparative values?
Yeah. So let me explain. So it's a shape effect, right? So in the case of a wing, it is shaped like this, right? It's shaped like this. So it can flow out like this, right?
Oh, you mean the two wings of a plane go out like this?
Yeah. So the movement of the fluid is along the wing, which is shaped like this. So it can move faster.
Shaped like this.
Yeah, it's like that overall. So it can move faster.
Well,
on top, it can move faster.
It's like a teardrop or something like that.
Yeah. So that it can move.
The air is flowing over.
Yeah, it can move faster. It can move faster, right? On top.
Well, it moves slower, doesn't it? It moves slower over the top.
No, faster.
Oh, I see what you mean. Yeah, it would move fast.
The Bernoulli effect pulls up because the top of the plane's air is faster than below the plane's wing. May I bring an important point in here, namely that the flow speed in my model, when you would make such a flow wing visualized model, is the speed of light. So when you make the speed of light, then you get a time which is maximum, and that is the speed of time. And I have a book of relativity here, which is not using algebra to show the exact effects of not just special relativity, but also common relativity. And this is not an approximation. You can do all of relativity in geometry, as shown by this book. And to make this book geometrically work, the author starts with the following. I could bring the book down and show you the page, but what it basically summarizes, because it's so simplest, think of a 360-degree circuit, Euclidean, standard circuit, okay? Make a sector, top left sector of that, and you have an x and an y axis, and make the speed of light scaled between 0 and 1, or 0 and 299792458, that doesn't matter for the argument. And the x-axis is the distance to travel, and the y-axis is your time axis. And normally you don't have a time axis. You have a geometric time axis in 4D relativity theory, but this is not the time axis. What I mean, you think our time, and you are sitting at rest at the current space-time position relative to us. We are sitting on Earth, and we are not moving at the moment because we're sitting all on our chairs, and Earth is a rigid body. So we have at the moment no relative speed relative to us three, right? So with respect to that, on that diagram which I was mentioning, our relative speed is 0 at the moment. So we have no additional mass by movement, and we lose no time by time dilation from the mathematical arguments of special relativity. And now think, you would, while you are at rest, travel through a medium which flows like time, passes through you, and the time has the same y-axis number than the x scale. So if you take 299792458 to the right, then you have to define your time in 299792458 times n steps. But it's easier to argument when you say you have the speed of light between 0 speed and 1, and the time between 0 time and maximum time is 1. That is easier to argue in the square root. Now, when you want to calculate the relativistic effect, you say you have 45 degrees in the angle, and you make the secant and the horizontal cut off, then you get exactly the time dilation on the y axis, and you get the length contraction on the x-axis. That's simple. Theory of relativity, and I'm not talking about special relativity.
Yeah, I think there's a problem.
It's exactly the root. This is so simple. This is sheer unbelievable. And when you assume we would travel, when we are at rest through time with the speed of light, and you start to accelerate a spaceship or an electron in an accelerator until it is close to the speed of light, then this electron has no more length it could pursue. It doesn't come to 1 because it shrinks until near 0 length. It becomes flat, like a disk. When it was a ball before, or a horn tube shaped, it's still when traveling near the speed of light and looking from the side, it is like a disk flat. And that is because it contracted geometrically with theory of relativity, and then the time has no time to flow anymore, and hence for a perfect photon, it has 0 time, because the perfect photon has maximum speed on the x-axis. No, it has 0 speed on the time axis. And that's why the time is at stop there. While for us here, this is reversed. We flow with 1 to the time axis and 0 in the x-axis. But we can change, we can take a fast car. And when we have a fast car, we have a little bit relativistic effect. When we take a fast rocket, we get more relativistic effect. And when we would have infinite fuel and accelerate until we're moving half the speed of light, then 2/3 of our time we would stay younger from that kind of mathematical. It's just algebra, geometry, very simple.
Well, so go on there, Rajan.
This is the argument for Rajan, because this is the fluid we're talking about. Time is the fluid where your Bernoulli effect could happen.
Oh yeah. So one of the things I was saying
to make there, Rajan, it reminds me of that video that was popular a while ago, where someone was talking about a 5th dimension, which is just a 4th spatial dimension, and they're saying that if space-time is curved, it's like a hill, so you're walking along the flat, and then the person has to walk up the hill, so it takes them longer, Well, how do you say it? Because it's the same with the wing, right? So you're going underneath the wing, it's straight, you go over. But it's more to do with curvature. So time is slowing down for them because they have a longer journey to make when they meet up again. The two paths have to be.
Time would consist of quanta, and the time would flow below the wing. Then the distance to fly for the time quanta particles, think of time particles. When you flow in time direction, time particles flow on your wing, and the wing distance lower the wing is shorter than the wing distance over the wing.
Right, but is it true that when with the time-space curvature analogy, if you will, the 2 points have to meet up simultaneously because it's time. There's an event there, but with a wing structure, you have like 2 air particles, or you don't have air particles, but just imagine you did. And
that's the same from you need a medium, in other words. This is
okay. So you have these gas particles, and then one goes under the wing and one goes above the wing. Now there's nothing to say that they have to meet up at the same time at the end, do they?
They don't. Why should they?
So I mean, maybe okay. So you're saying they go faster. I mean, they have more energy or something.
This is what relativity is telling you. When you bend space-time, then the time for you...
No, sorry, I'm just talking about the physics of the wing here.
It's not as it looks at first sight. I think I like the analogy because it's easy to understand, actually.
Yeah.
Right. So is this what you're trying to get across, Rajan, that there's this...
Right. One of the things in the classical mechanics is the conservation aspect. The flow, why is that velocity times pressure is constant? It comes from the conservation aspect. Conservation. It's a simple conservation of mass. So when the fluid is moving, the same amount of fluid has to move through. That's the whole idea. So when you calculate that, the flux, if you calculate that, you will see that the faster the on the top of the wing, it has to move faster. You can actually derive that very simple from the conservation thing, and it's derived. I mean, if you look at the book,
I think I got that wrong when I was a kid, and then I've just since then continuously made that error, despite being corrected about it. So continue on.
Yeah. So this is a quantum effect. What you are talking about, the quantum effect with the time and everything. I think it will come to be the same kind of thing. We are looking from the quantum side. We'll get the same result. So we can convert the Bernoulli effect, the mechanical effect, into the electromagnetic effect. I think that's something we can think about. I think it's a very nice calculation we can make, computational physics we can make. I think that will explain. Suppose on top it's moving like that, right? So, suppose I have some other mass is going to move and create that very similar to the space. The space is bent in a bend. So Einstein is partially right. The thinking process, the conceptual aspect of bending of space is correct. But I think his calculation, like Christine is pointing out, from the idea of light and things like that, it's unnecessarily complicated. I think this is
it is complicated.
Yeah. So I think there's a simpler.
I have my theory that I'm working on. It goes up to maybe special relativity, but maybe not even. And then I think I'll just work on my the area I'm working in.
Your thing is good.
It's like people working in relativity, if they want to continue it on into their sectors, that's fine with me. But I don't know. I just can't deal with it. It's too messy.
Christopher, I think I was thinking again about your Maxwell equation and the fact that my modified equation will change the B value. I think your equation is quite solid because you can use that. Yeah. So you can use the modified thing. I think will explain a lot of the things. You have to just put them together. Just put them together.
No, I'm not disagreeing with your equation in the slightest, really, but it's just that I need a gradient field in order for it to work. So that doesn't have to be just an electric field. It could be like a gradient magnetic field. Yeah. It is. So, but I'm thinking that magnetic creates electric. So it's like Christian was saying there. It's not electromagnetism. It's magnetoelectricism. So it's the inverse. So then we wonder if this might not have a slightly different effect in our reality to be more, how to say, gravitational. It appear more like a gravity thing.
It's an appearance.
Well, but then there's the question gravity works on non-magnetic objects, so. But then
it works on the box.
Charge that pulls in bits of paper and stuff.
But I think at the bottom level, the quantum level, everything is magnetic. But they get, like he said, the speed of light is because. Okay, let me tell you about the light. It's about the speed itself. Very simple equation. You start with space and time. You derivation of ds by dt is your velocity, right? So when d square s by dt square equal to 0, you get ds by dt becomes constant. When it's become constant, ds by dt. dv by dt becomes 0, which means d square s by dt square becomes 0. So when you do that, you automatically see why the speed of light, it can be either a constant or 0. So these are the two values you get.
Okay.
When the acceleration is 0, you either get a very simple calculus. So when acceleration is 0, you can either get a constant or equal to 0. So that constant is the speed of light. So which means that the speed of light, the two solutions to that problem automatically tells that there should be, you can have two entities. One is the light, which moves at the speed of 3 to the power 10 power 8, or more accurately, the numbers, or it can be at rest equal to 0. So both of them will give the same result of the acceleration being equal to 0. The acceleration becomes 0 at the vacuum because like I said, the multi-phase, superluminal thing and the subluminal thing. They come together and they cancel each other. So then you get this constant speed of light. So you have the acceleration cancelled out. So you have an acceleration coming from this side, they come together and the acceleration cancels out, that becomes vacuum. And there you can either have a rest thing or speed of light. So that's why you see the particles. When the particles form, they can either stay there or it can pop out. You know. So
have you ever thought why the electron, when it's electrically charged and makes a field which we can visualize in computers and very well understand, like in graphics, which I've shown, or Emmanouil's graphics. Think you have a charge, and that makes this field. What would it do? It will not be static. It will rotate on the body to stabilize itself. It will have the spin or whatever, the quantum mechanical. But in the end, from me, it's logical. It's a rotation with the speed of light because the whole subspace vertices rotate with the speed of light, and hence everything light has to fly with the speed of light in this field because the field in itself is rotational movement, and the light is going not in a straight line through that, but a circumpolar. Actually, its geometry is like a circumpolar wave where the wavefront is rotating like a helix, and when you look from the side, it looks like a vector field of magnetic and electric field, but essentially it's a much more complex geometrical object. And the geometrical object fits naturally to the rotational vertices of what I call subspace, and other people just call space-time. When they want to say relativity, we have nothing, but that is just a light to their own pocket, left pocket and right pocket, because what would a particle and an antiparticle make different? Recent accelerator experiments in CERN have shown that the antimatter is also falling down, and I had hoped that, okay, because I would have been very concerned if that would not have been the case, because from my point of view, what is antimatter? Antimatter is matter with opposite charge. So how do you get a charge? Now think, again, just a model, but it is reasonable to think that way. When you have a field magnet, a single one, and have a cubed one, okay? Then you paint half of it red and half of it green. Like you buy such magnets in the shop, they're typically just longer, but think of it as really a cube. You buy one of these high-end neodymium cube magnets and paint the upper side red and the lower side green, that you understand the field direction. You do that with each of your magnets, okay? Now the cube magnets can be glued together easily, red against green, against red, against green again, and you can make a long line of magnets if you want, or you can make a line, a row, where alternating, then you make a chessboard of these magnets when you want, because they had opposite field, up, down, up, down, up, down, will just glue together. And you can make a three-dimensional thing of that when you want that. Now, when you take an odd number of magnets, not an even one, an odd number, like iSpace theory dictates, and I make a Rubik's Cube out of 3 × 9 of such magnets, then I get a charge up, down, up, down, up, down, which irons out to 0, where red and green keeps off to 0, but in the center is a single one which doesn't keep off. The magnet in the center is 1 magnetic charge more, up and down. And when this is your field line, you have 1 electron. Now, when I remove the center cell and construct a hole in there, then I get a neutron, because I removed 1 of the charges, and the thing is now, because left, right now neutralizes, and is completely neutral from an aggregated point of view. The local effect is not neutral. When the thing rotates, you have all these magnetic effects in the G-2 0 because of that. Just from a model. It's not nothing.
Why though, if they're all cancelled out, why do they start back up again when they rotate? I don't follow that.
No, the space-time rotates, and if the space-time consists of such things, then it's clear why you have a single charge when you have the whole filled, and you have not a charge when you have the whole not filled. But now comes the cool thing.
Okay.
When you fill the hole and reverse the single cell in the center from red-green to green-red, then you get an antiparticle.
Oh, right. So it's like a Rubik's
But the mass of the magnets is still exactly the same, and they're rotating with the speed of light, and they do exactly, mass is mass, okay? And they attract with the magnetic force each other, because the whole subspace is attracting magnetic mass like each other, like normal magnets, tiny, tiny magnets, and everything is constructed out of magnets. And when you make the magnets rotate and they are iSpace symmetric constructed, then you have a center hole where you can decide, is the magnetic pole of the center hole up or is it down? Now, when you have a three-dimensional magnet and the three-dimensional Rubik's Cube, you have a pincette or something, and the magnets are very hard to manipulate, but say you have a robot doing that for you, and the robot is turning the hard forces of the inner cell of the Rubik's Cube in the reverse direction, it doesn't feel right, because it would be an asymmetry, and the forces should not be really symmetric if I leave it just to the hole. In the whole case, it's still symmetric. But when you have 6 dimension, that is no longer the case, because your hole is not where you think it is. You do exactly the same thing now in 6 dimension with the exact same magnets, and suddenly you have a full symmetric magnetic field. And I have inside the magnetic field in the geometry the ability to put a single magnet more in. Then I have an electron. I reverse the single magnet, then I have a positron. But the number of masses in other words, the number of magnets I need, or magnet cells I need to aggregate until I have my electron done, is constant. So in other words, an electron's mass consists only of electrons, of magnet balls. And I can tell you exactly how many, because the iSpace theory found out it's 1, 1, 1, 1, 1, 1, plus 2 for the borders. It's 10 times plus 1 times 10 plus 1 times 10 plus 1 times 10 plus 1 times 10 plus 1. So in every space direction, in every subspace direction, you have 10 magnets in a row, and you add 1, and then you start rotating that, and you take the next dimension and take 10 times more and add 1, and 10 times more and add 1, and 10 times more and add 1, and you add a complex 6-dimensionally rotating Calabi-Yau thing with exactly the number of magnets I told you, 1, 1, 1, 1, 1, 3, 0 magnets, and then you multiply my geometry, and voila, you get up to the last digit the electron mass you find in the books in the SI system. That's simple. And that's why that is more than a model. That would not be possible to get the exact value from such a simple model. Wouldn't there be some physics behind it which is real?
Well, yeah, it's an interesting thing. I've been thinking about your space-time bending thing with the torus and the cube a bit more, and I think I have it figured out more or less. So you're saying, let's say you have the cube, and then we stretch it to infinity along the x-axis.
Not infinity exactly, but as long as you wish. Yeah.
Yeah. Well, we'll have it as infinity because the x-axis is infinitely long, and if we need to join up the two ends, then that's going to be at a point at infinity.
But then you bend the whole universe.
That is, yeah, but that's what I'm saying. You'd have to do.
I bent a Calabi-Yau space. This is a microscopic.
No, but you're talking about, it's not Calabi. You're talking about x, y, z, and then the
Rubik's cube. Remember, you start with Rubik's cube, and you have Rubik's cube system, and then
the minus sides of those same axes are it's still three-dimensional space. So
it's not. No, it's not.
Yeah, it is.
No.
X, Y, Z plus the minus versions of X, Y, Z.
Every spatial direction is 90 degrees away from all other spatial directions. You're not right.
Well, not if they're just plus and minus, which is what you said earlier.
I take the plus and minus to make visualize what I mean, but it is not taken to be linear geometry on an x-axis.
Right. Well, then you're talking
minus x and plus x is in the same axis, namely the x-axis.
Well, hang on.
The x dash direction is a 90-degree shifted direction in subspace.
Together, then that's going to be happening along the x plane. I guess probably through the x, y.
Let's give the things proper name. Let's call it x and x dash, epsilon and epsilon dash, and z dash direction. Is that better for understanding?
Oh, yeah, that's cool. Oh, no, sorry. When you said earlier it was x plus and x minus, so, you know, I just take you
wrong words for the right model. So sorry.
Another way.
Yeah, I'm not sure about this. How, like, because you could just use.
Let me make a painting. I make you a painting. Really, that is necessary now.
Yeah, I think so. Visual thing would be perfect here. Yeah.
Yeah. Another way. another way to look at the three-dimensional versus six-dimensional, I think, is that three-dimensional, if you look at that, if you invert that, it inverts, inside out of the three-dimension, then you get six-dimensional.
And make a painting, and you see.
I think we can think about that. I think that will work out. Inside out of the.
What you're saying, Rajan, three-dimensional into six-dimensional.
Yeah, it's like this is a three-dimensional object, right?
Yeah.
So that's a static three-dimension. Now I pull everything out. I pull everything out from that three-dimension.
So this is what you learn at school. I'm not sure you can see that it's three-dimensional and has 90-degree angles between that what I have drawn. Does it make it clear? Yeah.
Yeah, I can understand that.
Okay, cool. Now let's draw a smaller cube that you see the whole cube direction. That makes it easier to understand. So that is what I call a three-dimensional cube with three vertices visible and three vertices not visible. Okay?
Yeah.
Now let's make the cube six-dimensional. How do you do that? When you do an iSpace cube, with pi equals 4, this is just for mathematical reasons easier to explain in a pi 4, but there is also a pi 3 cube. It doesn't matter. It looks in two-dimensional like this, like a Rubik's cube, yeah?
Yeah.
And now let's make it a three-dimensional Rubik's cube. It has 27 cells, nothing special here. And the Rubik's cube has a center cell on the left. Can you see?
Yeah, but how is that pi equals 4? Would that not be pi equals 3?
No. This is a pi equals 4 because you have 8 around 1, and 8 around 1 gives pi equals 4.
8 around 1?
8 cells around 1 cell is pi 4.
Oh,
because
yeah.
the circumference is 2 times pi times r.
Oh, yeah. Okay. Yeah. Fair play. Right. So you've got this 4 times pi. Is it a cube?
This is a square, not a cube. But everything in iSpace is three-dimensional. You have no flat things. So you have.
Do we need the pi equals 4? I mean, it would just work with a normal cube, wouldn't it?
No. When you have a Rubik's cube in your hand, then the circle in the Rubik's cube is seen in front of your eyes is an iSpace circle with pi equals 4. There is no magic. It's just pi 4.
Okay, but it's not relevant. Is it crucial to have that ingredient to explain the point?
You have a pi 3 circle, which is a little bit more difficult to explain, but not much. Then you get constants of nature. With the pi 4 circle, you don't get constants of nature.
We're just talking about the geometry, though.
Yeah, it's just about the geometry.
Just let's leave out the pi 3 and pi 4 if it's not crucial to the geometry.
It is because.
Oh, okay.
This is x, y, z. This is the same three-dimensional thing, x, y, z, on a three-dimensional Rubik's cube. Okay.
Yeah. So it's a three-dimensional cube.
Okay.
Yeah.
And how to make it six-dimensional? I show you.
Okay.
So, have you ever had a TV with 3D glasses?
No.
Most people have not. So I have shit like that at work. So this is what we need to assume you have here for the sake of the argument.
On TV when I was a kid with those red and blue glasses. So, yeah.
Give me a second. So, x dash, y dash. I should have made it nice. Oh, let's make it nicer. So this is really not good.
Another thing, I don't know whether you can see this one. Another thing is that cube, when I unfold it, you get these things, and then like that, all the 6 sides. When you unfold it, you get the 6 sides, right? So I don't know.
No, that has nothing to do with that, Rajan. This is still three-dimensional. The cube is a three-dimensional entity.
Are you, Rajan?
I'm talking about. Unfolding is inside out. So I make a project. What you call the projection? Is it called a map? What do you call it's called a map. Is it called
again? No, it's a net, isn't it?
Net. You're absolutely right. This is called a net. So I create a net for this cube, right?
Yeah.
So I pull out, and I have 6 like that. So I am showing only the 2. There are 4 more. So I get the net. I make the 4 net.
You're saying. So this is how you turn 3 into 6. Is that what you're trying to get?
Yeah.
Oh yeah. Okay. And then so
exactly right. Net. It's called net. That's the geometry.
Yeah, I was interested in all of that stuff for a while. So so I'm just trying to visualize this this cube, the cube being glued together on all sides, and I think I came up with a good way of doing it. And
give me a second, and you see.
Dimensions. Well, no, you need you do need a 4th dimension to do it properly.
Oh yeah. So actually glue it together. You see, I mean, we can actually, it's like a Mobius. You can kind of think of this is like a Mobius strip. This each part of the net becomes like a Mobius strip. And then you glue it together, you can get a 4-dimensional space like torus.
Rajan, Mobius strips don't exist because you cannot ever have anything 0-dimensional. They just don't exist. They are a mathematical thing. You cannot ever construct something. When you take a newspaper, cut a stripe out, take some glue, rotate it 90 degrees, glue it together, then you have something which feels like a 2-dimensional Mobius strip, which is infinite in further movement. But when you put it under a microscope, you see 3-dimensional atoms made out of your paper. It never is a Rubik's Cube. It is iSpace, even when it is a newspaper. Don't try to visualize these things as 2-dimensional because that hurts my inner feelings, really. This is wrong. Everything is atomized. Nothing is 0-dimensional.
Yeah,
that is the whole problem with mathematics.
Actually, I mean, you can just use a thin piece of paper and you can kind of make the geometry. But then, you know, the point is it one-sided? It's one-sided if you're traveling along it, but everyone can see that, no, it isn't.
That's a good point about 3-dimension. How much you can unfold, right? So I said the cube you can unfold, but when you unfold, or what I call create the net, when you come to the Planck limit, that's the limit. You cannot do any more.
Oh, yeah. Well,
that's the thinnest.
The thing I'm confused about the Planck limit is, you know, the way, is it different for different sized particles with different masses? Or have they figured out a way of making it the same for everything through like Noether's theorem or some similar thing? Do you know? Maybe not. It's a bit of a specific question. No, that's fair enough.
Okay. Guys, I have made now hopefully a drawing which makes some sense to you. I have
3D.
Two cubes next to each other, which can be easily seen. There is a viewer in the front by these eyes and glasses. Yeah. And you assume now that you look on 2 TVs, 2 different TVs. Okay. Each TV is showing 1 cube. Okay.
Yes.
Just that you understand what I'm trying to do here. So
yeah.
Look at the left cube shows the left cube. Yeah, the left. So this one here, from my perspective, shows x, y, z and is 3-dimensional. And you see the minus x, minus y, and minus z direction on the paper of the left cube. Okay, this is strictly 3-dimensional.
Oh yeah, I see that, Joe. Yeah.
Okay. So now look at the other cube here. The other cube has nothing to do with the left cube. It is on a different universe, a different TV. Okay?
Okay, yeah.
And the different TV has not x, y, z directions, but x dash, y dash, and z dash direction. And it has, of course, minus x dash, minus y dash, and minus z dash direction. And they have nothing to do with the x, y, and z direction. Because I can rotate the second TV in space of 3D in my home living room by 90 degrees or by 180 degrees. I can flip it on top. I can do whatever I want with the right TV, and the left TV is not affected. So the axis of the right TV are 90 degrees interlocked in the Rubik's Cube. The axis of the left TV are 90 degrees interlocked, but they are mutual independent.
Okay.
So if you see that they should be logically connected, I just tell that they are not completely disconnected, but they are a logical enhancement of the first 3 directions. You have 3 new directions. You have x and anti-x, y and anti-y, and z and anti-z.
Okay.
And this gives 6 directions. independent directions, okay? Because I can make a direction movement on the right TV or a movement on the left TV. And a movement on the left TV has nothing to do with the movement on the right TV.
Okay, how does this help your argument about the glue?
Now you pull up your 3D glasses.
Yeah.
And I show you a 6-dimensional body which does crazy things in your 3D glasses thing by moving the right and the left positions of the cubes in a way that they are become 3-dimensional in front of your eyes. Just by normal perspective theory. Okay.
We know they're 3-dimensional. Oh, okay. You're going to do something to make it. You're going to
so
reduce.
When I create a Calabi-Yau space out of such a thing.
No, you can't. Well, maybe you can, but
of course I can.
Well, I don't see how you could do that with what you just showed us there.
Look, again, when you have a grid which is 3-dimensional, this is now really too hard to paint for me. But think of a 3-dimensional grid with a 1-meter grid distance, please. Okay, and fill the whole universe in spatial XY Euclidic direction and forget relativity for a second. Okay.
Oh no, I have to forget about relativity. What will I do?
Yeah, I know this hurts. Take a beer or a liquor or something and forget relativity for a second. Okay, just do it, please. Yes, what you have is Euclidic thing, like they looked at the stars before relativity was invented. Everything is Newtonian, everything is Euclidic space, 3-dimensional. Okay?
Yeah, okay, yeah, this is where we started from.
A Rubik's Cube has 10 centimeters of diameter, about. Okay. The cube intercube distance is 1 meter. So a Rubik's Cube's left end is 1 meter away from the Rubik's Cube's next left end. Because all Rubik's Cubes are centered on their positions and the group grids.
Yes.
So a Rubik's Cube has a center cell, obviously, and the center of the cube of the center cell, which are easy by diagonal triangling, is exactly positioned at the grid coordinates.
Okay.
That gives you a center position which is exactly 1 meter away from the next Rubik's Cube.
I don't know. I feel like you might be not explaining this right, because I mean, you had your explanation at the start, and now we've drifted. I feel like
I tell you the same thing over an hour now. The space is filled with a medium, and I try to explain you the geometry of the medium.
I know we're talking about something completely different again.
No,
I'm just looking for geometry, like plain and simple.
Look,
how does this?
iSpace theory has a mathematics which gives constants of nature by showing it's 10-dimensional.
I think you were right when you said it was 3-dimensional and you're counting the plus and minuses as 6 dimensions. So
no, that is not a different dimension. That is just minus 6.
Right? Basically, I was just listening to what you said, and I was thinking about it, and I said, we have the cube. Now we extend it out to infinity, and then you glue those two ends together because they're plus and minus.
Christopher, in iSpace theory, you cannot bend Lego. You have not the option to do what relativity is doing to Lego.
That's the whole thing that you're saying, that you bend the cube around to so that
in space-time. So you have a 10-dimensional space.
No. Forget about that. You don't need to worry about that, though, because you don't need space-time or 10 dimensions. You just need.
Of course, I need that. When I have 10 dimensions, I need to point like in string theory has for
I'm telling you now, Christian, that you wouldn't need that. Okay. So let's say you had a cube on the tangent plane, and it's touching the surface of the sphere. You can just bend it around the sphere so it reaches the top.
Christopher, with all due respect, you're trying to explain iSpace theory to me without thinking to the end. And I know that a little bit better.
I haven't, wait a second. I haven't finished my point yet. So you listen to it, then afterwards you can say, this is why you're wrong. And you keep it brief. Maybe 1 or 2 points, then I'm going to go get a cup of tea. We'll have a break. So the point I'm trying to make is, let me start again from scratch. So you have the cube. You stretch it out to infinity, and then you can unite those two things at a point at infinity. You can do the same with the y-axis, obviously. But if you want to do the same with the z-axis, you need a 4th dimension.
Correct.
And then right, and so that would be it. Then they'll all be united at a point at infinity. On the hypersphere, which is a 4-dimensional thing.
Yes and no, because God does not prefer the x direction. And here's your problem.
No. All of these directions are completely the same. They're all united at a point at infinity. But then, because it's 4-dimensional, It needs to be projected back into the 3D tangent space. And then
this is exactly what where the things get wrong, because that is all thinking which you can only do when you can bend your Lego, and you cannot bend your Lego.
Earlier you talked about bendy Lego, and you're also talking about bending the cube in.
No, I did not bend Lego. I bent space, which embeds Lego in a way where it is not recognizing it is bending.
You weren't talking about bendy Lego earlier. I have it on. We have it on video. So
okay. You know, you always say infinity, and infinity is wrong. Infinity doesn't exist either.
Well, no, but we have a
point.
You have a point at infinity that I'm talking about. This is what we use in the tangent space model with the sphere and the exponential map. It's all part of general relativity as well. This geometry of the Riemann sphere. The Riemann sphere is a point at infinity.
Is there any specific reason you don't want to go past 4 dimensions? So this is what I don't understand.
Well, we don't need to go. I'm saying
that you need because of symmetry. This is the mistake.
I think you don't need to. I think you can do it with just 4.
God does not prefer the x-axis. Full stop.
There's nothing to do with it with the x-axis.
It has everything to do with it. Unless you don't understand that, the discussion is more.
Prove it in the next few sentences, and then we go.
We don't bend x or y or z. The problem is x and y is still 3-dimensional when we bend. Is still 3-dimensional when we bend. But bending the inside to the outside is no longer 3-dimensional.
Yeah, it's 4-dimensional.
Yeah, then it's 4-dimensional, right? And God loves the z-axis. Congratulations.
Well, that's what I said. It's 4-dimensional.
When you see him, why he loves z direction and doesn't do that in x and y direction.
But I wasn't, yeah, anyway, so that's what I said. So you're agreeing with me. Thank you. I'm going to go get a cup of tea now.
No, I'm not agreeing with you at all. I'm agreeing that if you bend something, then you bend it symmetrically, please. You bend x to anti-x, y to anti-y, and z to anti-z, and then you get 6 dimensions and not 4. And exactly with that 6 dimension, I can calculate constants of nature and not with 4. And that has something to do with it.
So, Christian, look at. So one of the things is a cube inside a cube. I don't know whether you can see that.
As a hypercube, of course, yeah. But yeah, hypercubes don't exist in this way. Huh? This is a super bad model of visualizing 4-dimensionality. I hate that. This is wrong.
No. You convert it. I mean, you start with this cube inside the cube, and then you can convert it into 4.
I know how the mass of the cube you show me works. This is in all books, but that is wrong. This is the wrong model. It does not work that way. This is complicated like hell. This is what you do when you think you have 4 dimensions. Then you need to do all what you try to explain. And that is all mathematically correct, what you try to explain. This is all about relativity is working like relativity. And I'm saying that is nonsense because relativity has nothing to bend. When we have Lego, we need another model. Another model. And the model who works for constants of nature is iSpace. And that makes some sense. The problem is that you don't accept that we need 10 dimensions as a complete number. Yeah. 3 that we can live in, and 6 that we are consisting of.
Okay, but even with the cube inside a cube, the smallest cube we can have may not be 0.
You cannot have a cube inside a cube. That just the sentence alone does make absolutely no sense.
No, like a package. You have like a package. You put a smaller box inside. You know, like that, smaller and smaller.
Rajan, I give you a simple example to make the problem more visual. You sit on a chair in coordinates x, y, z relative to equator on Earth, right? Some position where your GPS could tell me the position. Okay? I'm sitting in a 3-dimensional chair on my position here on Earth. Now, let's move by software my chair to your direction.
Okay.
At some point, I receive your room, and you will see me both on your camera, right? When I'm in your room. And when I move further, I hit you. I hit you because you're a massive particle in 3D, and I'm also a massive particle in 3D. I cannot be in your chair because you are already in your chair. Okay?
Yeah.
So, and now your room is x, y, z, and make my room anti-x, anti-y, and anti-z. I'm still three-dimensional. I'm still talking to you. You see no difference from a screen point of view or voice point of view. And now move the anti-X, Y, Z position to your position, and I don't collide with you. I can sit at exact the same position you are, and you're transparent for me. You're not even existing for me. You are in a different space.
That's a holograph, like a hologram type thing.
Yeah, if you want it to call it a hologram, but I'm real. I'm not a hologram. I'm real. You are real, and you are real in your space, and I'm real in my space.
That's superposition.
And if I move my space to your space, nothing collides. But you would feel my gravity.
Yeah, that's superposition. But the photons cannot do that. Photons cannot do that, right? Photons cannot do that.
I'm not saying that massive matter can do that, but I can say quanta can do that when they are consisting of that, what happens inside the six-dimensional boxes. And that is exactly what superposition means. Superposition means that 2 or 3 states can be in one of the same space at the same time, fully valid in parallel. This is exactly what the atoms do. Atoms get superposition states.
Oh, but okay, that's true if you convert the particle into a wave. I don't think a particle, if it's
it doesn't need to be a wave, it just needs to be the right geometric model. If the geometric model allows that, you don't need to have a wave.
No,
it stays a particle.
An atom occupies a very finite space, right? How can another atom occupy the same finite space?
It can, because every atom in my model has its own subspace with it. It is a box, but this is not the box in the same geometry. It is an independent box.
But in the real, you cannot do that. In the real,
no, of course, it cannot do that in the real, because the real is 10-dimensional. That is the thing. In 3-dimensional, you cannot do it, but in 10, you can. You have 6-dimensional subspace, and I explained that electromagnetism is the same thing. There is no magnetism and there is no electric thing. There is a force, and the force in X, Y, Z is magnetic, and in anti-X, anti-Y, anti-Z is electric. And when you make a wave out of that, then the electric and the magnetic wave exchange its positions in a 6-dimensional space.
Yeah, that I can see. But then you are talking about imaginary space and real space.
No, this is not. Yeah, you can take the imaginary mathematics, but you don't need to. Imaginary mathematics is just useless mathematics. Take integer values and count them. You don't need any imaginary things. Imaginary things you can't measure. But my things can be measured.
But how
they are real.
So how do you
They are not imaginary.
Our 3-dimensional real space, how do you convert a 10-dimensional real space?
No, this is nested. You have a lot of these Rubik's cubes, and each Rubik's cube has its own subspace in form of a Calabi-Yau
But what is
entity.
a subspace?
And the aggregation of all subspaces in a grid, is that what you perceive as a 3-dimensional spacetime?
Suppose I
and
have
the
this one.
coordinates between the Calabi-Yau space you can bend relativistically. You can change the 1 meter distant coordinates to 0.5 meter or even down to 1 millimeter, because the Rubik's cube and the Rubik's cube A and B can take the same space-time position in our 3-dimensional space. That is the cool thing. Then you have light. Light can be everywhere. It doesn't.
Light can flow into each other.
Particles cannot do that, and why can particles not do that? Because like in the atom, when it rotates to the right, it is allowed to be in the same position with a particle which rotates to the left.
Yeah.
But when both particles rotate to the right, they would have the same state, and they are not allowed. They would collide to each other, because when they rotate in the same state, they feel each other. Yeah. It's just a force field. They cannot be ever in the same position. But when they rotate in a different axis, they cannot see each other even. This is like a dot. This is not there. And then they can have the same position. So this is nothing really difficult to understand. It's just you have to really think 10-dimensional and not 3-dimensional.
I think what you are saying is implying is that it creates a hole through which the other can flow into. You know, the higher.
What I'm saying is all electromagnetism is happening in a box of finite size in subspace, bent to a Calabi-Yau 6D thing, or you cannot have standing waves. For a model with energy, you need standing waves. And the higher the number of standing waves, the more matter or energy is inside your box. That's simple, okay? And I can tell you exactly what the wave number is for an electron. Exactly. So I know exactly the box size of the electron.
No, it's called particle in a box. There is a model, particle in a box.
But the particle in a box model is not three-dimensional. That does not work. That's why all these people who have tried in a 3 or 4-dimensional world to make theories, to make relativity and quantum mechanics compatible, failed miserably, because you cannot make it in 4 dimensions. You need 10 to do that. And string theory is telling you that. The iSpace theory and the string theory has mathematically nothing to do with each other, but the relativity theory says you have 4 dimensions, and that is wrong. Whereas the string theory says you have 10 or 11 dimensions, and whether it's 10 or 11, I won't argue, but at least you have not 4. And that is compatible to iSpace. Because for logical reasons, I need 10.
That's because of vibration dynamics. The 4-dimensional still is static, I think. So you need 10-dimension, make it dynamic. And also,
yes, otherwise you cannot move. You have a brick of Lego which is sitting there and won't move. That is boring.
Yeah. So the 4-dimension also is static, probably. It's static.
If you not bend the universe, then it's static, yes.
Yeah. So you have to go to double that, 8 dimensions, not be dynamic, but the 2 dimensions that add up to take care of the vibrations or something like that, the spin or the vibrations.
I need 3-dimensional box for the magnetic part and a same exact size 3-dimensional box for the electric part, and combine them at the same space-time Calabi-Yau position to become electromagnetism. Okay.
Okay.
I need 1 dimension for time. Obviously, is 1/6961 is discrete ticking in the same pixel count, in the same size, and this is 7-dimensional. But we are obviously 3-dimensional people. So what happens? Atoms are, so everything subspace is atom space. This is 7-dimensional subspace. And we are constructed as 3-dimensional entities like Lego pieces together, which are very, very small. So our atoms we are made of, made our cells make our human body, and that is 3-dimensional. But when you look quantum mechanically at each detailed atom, you don't know what it is. It is hollow, it is empty. The atom is empty, there is nothingness, this is void. And that just reminds me on gravity. Gravity between galaxies is void. It is exactly the same fractal structure. And that's how it's working.
So what that's
and it rotates for stabilization and mass and movement. Yes, exactly.
So it's moving this way and this way.
Yeah. When you wave your hand on the screen, you're waving a 7-dimensional aggregate of subspaces in a 3-dimensional time plus space. Also 4-dimensional space-time when you want. Your hand is made of subspaces. You cannot do that in 3 or 4 dimensions. This is why I object, Christopher, here. Mathematically, you can, but it makes no sense. Because when you want to have it in 4 dimensions, mathematically, you have implied or explied tell that God prefers the X direction. And I don't like that.
No, I like it. No, I can understand from the static and dynamic aspect. The 3-dimension is still static, 4-dimension is still static. So you have to go to higher dimension to get dynamic. That's the way I see it.
To move an atom in 3 dimensions, you need to have a continuum and an atom which is part of the same dimension. This is model R. Or you have a 6-dimensional subspace plus time, and the time is the same in space-time and in subspace-time. So you need 3 dimensions more to move your 6-dimensional subspace in these 3 dimensions. So think you take a single electron and hide it in this Calabi-Yau space, and you say it should move from space-time coordinate 0, 0, 0 to 1, 1, 1. So it moves in a diagonal part through the cube of a 1 meter size. And the electron is very small, it takes some time. And when you have an old TV with a ray cathode tube, you can exactly see that is happening. The electron is emitted from the bulb in the tube, and then is in vacuum moving about 1 meter until it hits the screen and makes a dot on the screen. Okay? And what relativists and normal physicists think is that that was a 3-dimensional movement of an atom or an electron or an atomic particle, whatever you accelerated, in a 3-dimensional vacuum tube. But that is not at all true. What happened was that you moved 6-dimensional subspaces, which are rotating entities in 7-dimensional subspace time, and moved them in 4-dimensional space-time from one end of the tube to the other end of the tube. So you move the whole space-time. And how do you move space-time? Yeah, think of a submarine in water. How do you move a submarine? You move the submarine in water from A to B, and the water molecules stay where they are because they don't go with your submarine. Waves are standing in the water and don't move their position. The energy is transported over the waves' vectors.
This is because of the longitudinal versus transverse.
The atoms in the water are not the one killing people with waves on the shore. The energy of the up and down of the molecules in water are killing people on the shore on a tsunami.
So longitudinal versus transverse.
Yes, exactly. So when you have a 3-dimensional submarine in a 3-dimensional water, you can say everything is 3-dimensional. But when I tell you your submarine is not 3-dimensional but 7-dimensional, that does not at all change the argument. Then a 7-dimensional submarine is moving in a 3-dimensional water molecule entity.
So
and then you have 10 dimensions.
So it is actually a static space versus dynamic space. I would think.
Yes, space-time is dynamic. Space-time is nothing static. That is the point. That is all what I'm trying to express here. Space-time is violent. Space-time rotates, has rotating cells with the speed of light. It cannot be more violent, actually.
What is Christopher saying?
Yeah, sorry.
Yeah, block time is 4-dimensional space-time, and that's static.
Can you repeat that?
I was saying block time is 4-dimensional space-time, but it's static.
What is block time?
Block time is where you take like every frame of the universe and you line them all up.
Yeah.
Block time.
BLOCH, right? BLOCH.
Never heard that.
No, that's the block sphere. Or just maybe there's another block something. Block space, block time.
Block wave. Block wave. There's a block wave.
No, but BLOCK.
Yeah, like a cube. Yeah, like a cube time. You're saying, or
yeah, but it's so. Imagine you have all the frames of a movie and you stack them one after the other, and then you move through the movie. You can see it play. That's block time. But the block is static, but it's you moving. So you need a second time in order to do that. So, I mean, this is kind of relativity. And then if you're moving at an angle through it, then you're supposedly like Lorentz transformed. You know, you simultaneity doesn't, because something happening on a different time frame appears to happen on the same time frame as you, as your world line. I don't particularly agree with that, but I'm not an expert to say whether it's right or wrong yet or anything.
No.
But sorry, go on, Rajan.
Yeah, one other thing's very simple thing is that what is the difference between a movie and a cartoon, right? A cartoon, you create different images, slightly different images, and you start moving it, you get a dynamic effect. So I was thinking in IT terms. So in a video is nothing but you can actually do a mathematical thing. Video is equal to a series of images like cartoons moving within the speed, like it's called 1/16th of a second. So if it moves faster than that, it will appear as it's all moving together. That's how they created the movie to start with.
Cartoon is 24 frames per second, I think, is generally what we have in video. But you can have it up to 60 frames and whatever. You could have as many as you want, provided you had
but every cell on your pixel screen, when you make the screen virtual and you have in Stone Age your movie invented, then you would paint red paint, green paint, and blue paint on little squares of 10 times 10 centimeter. Sit your public area in 500-meter distance from a large wall and say, please be very, very patient. I show you now the first image. And then you take 16,000 of these papers and show an elephant. Yeah. And I said, please wait another hour. I changed the picture now, and you change the elephant to something that moves a little bit to the left. Yeah.
Well, yeah. Okay. I don't know what maybe we're getting off topic.
What I'm after is when you do it this way, then your screen is three-dimensional. Truly three-dimensional.
Well, to go back to some of your points you made, because I was out of the room. I think that was unfair, so I wasn't able to respond to any of it. But so I missed a lot of what you were saying. I think something you should consider here is that I'm not like attacking your theory. I'm not trying to break it apart and say you're wrong.
I never meant that.
No. Just to be clear as to what I'm trying to do here and what I'm getting at. So recently, I've developed a new model, as you know, called the unique hyperspheric model, and in that I use a lot of stereographic projections from unit spheres or hyperspheres to tangential planes and tangent spaces and stuff like that. So I'm just trying to apply what you're saying to that, so that there's a what would you call it? Like a hybrid model, you know, that we can find some bridge between the two models. Like the model is good because it describes the expansion of the universe, but it says that the universe is not expanding at the moment; it's static. But it also has the Hubble constant in there, which is pretty handy, and yeah, it has a lot of other good aspects to it. It describes what's going to happen at the end of the universe and how the universe began, things like this, and also possibly the charge of the electron and an antimatter speculatively could be described using the same model. So what I've noticed is that we could take your cube, bend it in all those directions using the stereographic model with a hypersphere. Now that would be four-dimensional, okay? Just the bending of the cube, but then to project it back into three-dimensional space, which is where we are, on the tangent plane. Now that's going to result in, let's say you have 1 point on the hypersphere. That's described by 4 coordinates. And then you have another point on the tangent plane. That's going to be described by another 3 coordinates. So in the tangent 3D tangent space. So altogether that's 7 dimensions. But these, you know, 3 of those dimensions will be the same as 3 of the others. But, you know, to describe the whole system, we're talking 7 plus the point projection point at x equals 1, or z equals, well, it's actually w, I guess, equals 1, is 8. Okay, so. But yeah, so
why 8 and not 10? When you have a point, which is the projection point, it should be three-dimensional orientable that you can project to any point in space, and then you would end up in exactly the same 10 dimensions where I end up also for logical reasons.
Well, there's no. Well, the space would be non-orientable because it's a projection of a 4-dimensional stereographic projection of a hypersphere, because everything outside the hypersphere gets. Everything in a certain level of the hypersphere gets projected out when it's rotated out. So it's non-orientatable on a 3D level, but on the 4D level, it's, you know, and infinite. It looks infinite on a 3D level, so space is infinite and possibly completely flat. But
this is due to the tangent mathematics gives an infinite impression automatically by the equation.
Right. So and then the hypersphere is going to be finite. So that's okay, no problem there. But yeah, so I just, I think, you know, like also I possibly have some sort of tie-in with the pixel issue. I haven't really gotten to that yet, so I don't want to say too much about it. But it seems like the pixels can stretch and do different things. But yeah, so it's worth considering what I'm saying, and possibly, I don't know if it's that really, if it's much use to you, but you know, it's worth considering. And then get
back to me. Would it be useful if you would take a full session day, like and tell us 1.5 hours full the concept from in a
yes, I will. At the moment, I have an assessment coming up, so next week is going to be. I won't be able to do it next week, and then. But maybe the following week I could do it.
But you're planning such a thing then?
Yeah, so I'm like, I have a certain number of slides already done. So I mean, it's possible I could get them finished by next week and have it done by Saturday, but they moved my assessment back. So yeah, technically
is
I have
it
more
based on the paper which I read, which you published a couple of weeks ago? I read this.
Yes, and not the assessment won't have anything to do with the cosmology stuff. That's purely, you know, it's anomaly detection. But yes, in the last maybe 4 or 5 papers, yeah, 5 papers that I published have all been about this unique hyperspheric model. And yeah, so there's a couple of papers in there about special relativity, and I was initially saying, okay, special relativity won't work in this model, which I was really saying is just absent from the model. But you could you could interpret certain ideas and resolve like certain paradoxes in special relativity using it. But by doing so, you winded up kind of toppling all of like special relativity just became nonsensical contradiction within itself. So I attempted to get those 2 papers published because I thought, oh, this is kind of cool. But then they were like, no, we do not publish papers that are critical of special relativity. So I was like, okay, that's fine. And then, but now I'm thinking anyway that the more I look into it, yeah, you could have certain aspects of special relativity in there, and you could also do some general relativity. But like I say, it's a sticky area, but it is interesting. I mean, there's a possibility. I know Manuel Malaver and other people are working on kind of fluid, you know, fluid mechanics in space-time. And then there's definitely some work to be done on the monopole issue. But yeah, so what it seems to me is that one of the ideas I've come up with recently is that possibly, this could be totally wrong, but just as an idea, so matter, normally when we, there's this concept that matter and space are the same because matter fills space. And also, and I think there's some torsion physics where it says that, oh no, matter is actually just space-time warped in a certain way. Yeah. So it's saying that matter is absolutely space-time. But I'm thinking, well, maybe, hold on here, maybe they're 2 separate things like oil and water, and they just do not mix. So we have like a matter space and a space space, and the space is as much as a material as the matter, but they're like completely...
yeah, then you have a hybrid model. Exactly.
One could be a medium. One like space could be a medium.
Oil and water is a pretty good analogy. So yeah, matter is like oil, and then the water is space. So there's stuff there. So, but then if we think about surface tension, right?
So you can also have vertices in water or vertices in oil, and then you don't need 2 substances. Because the vertices in its own build the vacuum-style holes in the fluid, which do particle-like operations in such a fluid.
Yes. So there's this is an issue. Like my idea could be totally wrong. So I'm you know accounting for that in a way. Like because if we talk about ethers, usually you know some sort of space-time or like space medium that, let's say, electromagnetic waves flow through. So if matter creates these waves and then they're supposed to go out from the oil-like substance, which is the matter, into the water, then you know it becomes a bit tricky. I was thinking about this as an aside. I haven't written any of this down, so I can't really remember what my result was. Oh, it was something like light is not matter, right? So light is a separate thing, possibly only transmitted through the water.
Are we really sure on this? Because I can think of a model where light is a positron and an electron interwoven into a wave traveling with the speed of light, and the only difference between the electron we have and the naked charge. The naked charge has no mass, and why is that? So, can I have 5 minutes? Because that is really an interesting, important clue. When I in iSpace multiply things together, I get the proper masses, the proper lengths, the proper time, the proper everything to get constants of nature. So I'm doing something right, okay? Just from the pure assumption, I multiply things and get constants of nature. I do not add things. I was talking to Harald, and Harald, I talked, the mass of the electron in an iSpace IQ unit system is this 1111130 plus geometry, like you multiply with the root of 2 times pi 3 and so on. But that is geometry. And I get the right electron mass. But to get the right electron mass, I need to multiply it with golden ratio because there is a charge. And I know from the equation charge is.
So what you're saying is that light is, you think light is some sort of matter, and I think that's
what I'm thinking is that the golden ratio part is the charge without the 1111111.
Okay, well, even like with your theory notwithstanding, I'd say that in conventional physics, you know, light is made of photons, and photons don't have mass; they may have a rest mass. So, and they're definitely a material. So
no, they have no rest mass, they have an impulse.
Okay, well, you know, some people think they have a rest mass.
Wrong.
So, okay, well, I mean, the theory of rest mass could be totally wrong as well. So
okay, agree. But then the space-time models of all of us would be something completely wrong under this condition. But I agree, it could be anything.
Yeah. Well, I suppose that you could say that today they have like a Planck frequency, which is converted into some sort of mass concept, energy mass. So
another aspect.
Be careful. Energy is not mass.
Well, it can be converted into it. Though.
No, it cannot easily be converted one-on-one. I
could be wrong, but I thought they did say that the photon possibly has a rest mass. Yeah. So anyway, it doesn't really matter. But I believe it's in the conventional physics. You know, light would be matter, but if it doesn't have any mass, so just energy, then maybe we could say that it is not matter. So then we go back to the point I was trying to make. So we could look at gravity as being a kind of surface tension then between space and the matter, or like the water and the oil. So matter has therefore a lower surface tension, and I think, and the water would have a higher one. And then we could describe all of this through surface tension mathematics, which has a lot to do with temperature for some reason. So then we'd be talking about the temperature of space, which is interesting, and then the temperature of the matter possibly as well. So, but just to get to another point, actually a point you made earlier at the very start of tonight's whole live stream, which I was going to bring up as well. And it's funny that you mentioned it in the way that you did. I thought it was very interesting. The metal ball on the rubber sheet. Now, of course, that's wrong for like loads of reasons. And you guys were talking about the incompressibility of space-time, which is also interesting, given that if space-time was a fluid, how could you compress it? But then normally when we think about most general relativity models, well, they're saying, well, it's not really bending or curving of space. It's like compression of space. But it's not really compression either, is it? It's probably more like bending into a fourth extra dimension, you know? So or you could look at that as perspective shift and compression in that sense. So, but yeah, so like if you have the ball is pushing down, so then if you're trying to bring that into a 4-dimensional or a 3-dimensional, that's like obviously a 2D analog of the 4D or 3D thing of like a planet sucking in the space-time around it. But then in order for that, you've shifted the rubber sheet into 3 dimensions, so you've plus 1 on that, but you haven't added an extra dimension to the ball. So you'd have to add, it would have to become a 4-dimensional ball to do the thing properly. Now you could have like a flat 1D disc of metal sitting and pushing, but I think talking about a 2-dimensional thing there, and then but you know what I mean. It's I don't know. That is a bit contentious in my opinion. But let's say we have the cube, a cube, and we're looking at it. So we have the front square of the cube, and then the smaller back cube that's backside that's further away from you. and then we have a surface tension on that. So when we're looking at that cube with the smaller cube in it, and we think of it as a two-dimensional thing, we're going to see the surface tensions kind of warping space-time here. And we're going to see it start warping on the inside towards the center thing. And the reason why I bring that up is because surface tension on the oil droplet, for instance, is only going to affect the outside, but it will not affect the inside. But as we know, the gravity field goes right through the surface of the Earth and into the center of the Earth. So we need a model that has this surface tension going right through the planet. And that's why I bring up the cube there with the apparent surface tension going right through. So if it's a four-dimensional cube, like I was saying, a four-dimensional material substance, then likewise with the surface tension, it would look like the surface tension is going in, but it would also be getting stronger at a certain point. So if this is the outside of the cube, I'm thinking it would look more distance perspective shifted, and therefore possibly more intense as you go inside, which seems to be counterproductive. But only up to a certain point. At a certain point, the surface tension would be coming right at you from your visual perspective. So then at that point, maybe it would look like there's no surface tension there at all. So that's just a few thoughts I've been having.
Yeah, I have just a couple of things. One of them is that the time space, I can think of the following way. Like I said.
Oh, wait a second. Could I just add one more point? Keep your thought there. So I also like the idea of surface tension and something to do with static, like you were talking about electrostatic charge earlier. I don't know why, but I feel there's a connection there. So that might feed into electrostatic charge and gravity. Go on, Rajan. You were saying something there.
Yeah. So that 10-dimensional space, I look at slightly different way. Maybe add up the thing. One of them is 3-dimension. We know about 3-dimension, but then you take the net and then inside out, you get 6-dimension. Then see, my thing is that there is 4-dimensional time. The time you can think of as, I have put the matrix as four dimensions. The time adds 4 dimensions. So you have 6-dimension, which is static space, and then you have 4 dimension of time, and they combine together, they make dynamic space. So 10 dynamic space dimensions. So 10
well, how did you get 10 there? Oh, you've got 4 and 6.
4 and 6.
4 and 6. Easy
so
maths.
Yeah.
But wait a second, you're creating the first 6 out of the first 3, so that's just back to 4 again, isn't it?
No. Once again, not, because you have a Calabi-Yau subspace.
No. Let Rajan answer, because it's his point he's making. Yeah. You have a cube which is in 3 dimensions. You've broken it apart into a net, which is actually only 2 dimensions anyway. So
and then you combine it back.
Made out of the first 3. So then if you add them back in, you see the problem.
You have to construct that. When you construct that, you will see. You can think of simple way: 3 inner dimension, 3 inner dimensions, 3 outer dimensions.
Oh, you're talking about some sort of subspace. Yeah, maybe, but I mean, we also have to not forget what we mean by higher dimensions. So we have, as we know, we have length, breadth, or X, Y, and Z, let's say, and then they're all 90 degrees. So the next dimension, the 4th one up, it has to be 90 degrees to all of those 3. And then if you go to the 5th dimension, another 90 degrees to the first 4 and 6, then that angle has to be 90 degrees to the previous 5. And that's how you build it up. And you cannot do it any other way. And that is where a Calabi-Yau space will live. It will live in a space like that. And that is a very complicated space. And
those are very simple space.
No, it is not. That is
super simple from my understanding. When you do the 6 dimensions discrete Lego and the 4 dimensions relativistic as we perceive them, and assume all our atoms are locked into boxes on 3-dimensional space-time coordinates, but consisting of 6 or 7-dimensional space-time boxes.
Well, look, what you said there makes no sense to anyone except maybe you. So the reason why I'm saying that is because you said
I think it's the most simple concept to understand.
What I'm saying is that you said it was simple, but then when you tried to explain it, I don't think anybody in the world understood that. I certainly didn't.
Could be that I'm lousy in explanations today, but normally when I tell iSpace theory to people locally, they easily grasp that concept, even at school level. Because it's easy to understand. No, you have a Lego thing which makes your concepts of nature, which makes your particles.
I mean, I understand like certain aspects of string theory, and I think that you're trying.
There is nothing to do with string theory. Nothing is waving around or anything in iSpace.
Well, no, but the higher dimensional aspects of string theory, Calabi iSpaces. But what I'm saying is, when you start adding these dimensions, things do get quite complicated quite quickly. Like if you wanted to draw a 4-dimensional cube, okay, that's not so different.
They're not complicated because they add nothing degree of freedom to assume.
Wait a second, just let me finish my point. If you want to draw a 5-dimensional cube, that's getting hard. If you go 6 dimensions, like that's like really hard. Actually, in terms of visualizing a 5-dimensional cube, that is very difficult and takes a lot of time.
Don't try, because that is wrong to even try. Why would you want something 5-dimensional? It makes no sense. Keep it 3-dimensional, because everything we measure in the lab is 3-dimensional. The last time
you're talking about 5 and 6 dimensions, so you need that many.
No, axes. You don't. This is a misconception of your understanding of what I'm trying to say. You don't need that.
I just said, like, if we're talking about higher dimensions, this is true. You need these extra dimensions, and you all agree.
If you talk string theory dimensions, then yes. But this is not what I'm saying.
Well, what kind of dimensions are you talking about? Because in mathematics, they use the word...
Rolled up dimensions are not the same than spatial existing geometric dimensions.
They are.
Theories, and I've read papers also string theorists from that who believe you have more true geometric spatial dimensions.
They have a spatial direction. So they have to exist at 90 degrees to the normal space.
When they rolled up, they are a quantum dot, like the electron in an experiment is a quantum dot.
The rolled up dimensions are straight out of string theory, and they're not what you described.
No, they may be straight out of quantum mechanics, actually.
Well, yeah, okay, Calabi.
Quantum mechanics tells you that the electron is a dot particle of zero length
extensively, and were popularized by string theory. So you know what I'm saying. When I say there's no need to be completely contradictory.
The 10 dimensions from string theory have mathematical reasoning, and only mathematical reasoning. There is no physical reasoning behind them.
Well, that's not true.
Theory, 6 dimensions have physical reasoning behind them.
No, well, it's the Kaluza-Klein idea of the 4th dimension that explains that's
the Kaluza-Klein theory has been falsified wrong.
I'm just trying to get a sentence out. So it explains how it's meant to unify electromagnetism and gravity with the 4th rolled up dimension. Okay, that's fine, but then that's where the physical interpretation of string theory comes in, that they say that the string is wrapped around these rolled up dimensions. So it is actually like, from a starting point, string theory is very, very much physical based, but as it goes on, I agree. Like they add in an extra 8 dimensions, which is interesting from what you were saying about your cube. But anyway, so basically they have these 8 dimensions, which is a bit like what you were saying on your cube, where you have pi equals 4. So there's like 8 squares around, and they all cancel each other out, exactly a bit like your Rubik's cube with the magnets. So they're just two extra probabilities, and I agree that does seem non-physical. It seems non-physical to me, but actually probabilities in quantum mechanics are physical, and they needed this anyway to get their right answers. So it would be physical in that sense as well.
Yeah,
so
but why do they need probabilities? Because something is rotating, and depending on the time when the particle hit, they see completely different geometrical results in their experimental results, because the particle is changing its phase to the experimenter with time. And depending on, he cannot control the time when the particles influence and hit on the target, and hence they have a statistical result. That makes completely logical to me from iSpace point of view. When you have something 6-dimensional and you detonate the 6-dimensional thing, then it depends on what your rotational angle of all the speed of light rotating vertices was at the time of detonation.
Right. Well, that's like QED or something, isn't it? Quantum electrodynamics.
This has nothing to do with QED math. It is probability of standard quantum mechanics. The probability is you have to repeat your experiment 1,000 times to get a consistent result.
Yeah, I don't know. So anyway, I was just explaining a small. That's the reason why they have those 8 dimensions. Is it? Yeah.
Another reason. Coming back to Christopher, you are 90 degrees orthogonality, right?
Yes.
For each dimension. Suppose you have solid angle. Solid angle is 720 degrees. So you can have 8 dimensions. If you divide 720 by 90, you get 8, right? So they can have at 90 degrees 8 dimensions. So you can get 8 dimensions from there.
Well,
the rotational symmetry.
Why are you getting your 7? Where are you getting the 720 degrees from? Is that
because it's a solid angle? Solid angle is 720 degrees.
Explain to me solid angles. I missed that.
From half
4 pi. 4 pi.
Oh,
solid
yeah.
Solid
sure,
angle is 4 pi.
But 4 pi is going over the circle twice. Yeah, so.
No.
No, it's not, because the particle is rotating 720 degrees until it comes back experimentally.
Well, that could be a different issue, though. You could explain that using 4 dimensions. I'm not saying, you know, or you could use it just explain it using 3 dimensions.
Which is precise on this. You rotate the electron once, and you don't have an electron after 360 degree back. You have the electron after 720 degrees back.
Yeah, I know, but
360 is a planar.
So what do you? Okay, so that's what you mean, is it, Rajan? You're talking about this solid angle, 720, and then yeah. So that's actually part of the logic I was using for spin 2 particles that have this solid angle thing. So that's why there'd be 8 gravitons. I was trying to link it to.
Yeah.
So I mean, I've looked into that kind of concept.
So you have orthogonal. Suppose x and y axis are orthogonal. That's a concept, right? So they are 90 degrees. So if you are 90 degrees, you divide 720 by 90, you get 8 dimensions. And then that's a rotation. But you have to have.
I don't know if it's correct, though, to say that you'd get 8 dimensions. Yeah, because you just have to be careful here. What we're talking about 8 dimensions, technically. Like, we're talking about 8 spatial dimensions would be like very, very, very complicated.
Like x, y, z, and then one more. Okay.
Okay. So here's a good point, Rajan. Here, this will explain it better, right? We have 360 degrees in a circle. Now we can divide that by 90 degrees. So does that mean that we have 4 dimensions in a circle?
Eventually,
no.
That's what. No.
The answer. Correct answer is no.
No. Circle is a projection of Circle is a projection of the 4 dimensions into 2 dimensions.
Well, hang on a sec. I mean, I'm not.
So suppose I'm looking at
a circle. A circle is 2-dimensional. Yes, that's the point I was trying to make at the start.
No.
Circle is 2-dimensional. It has 360 degrees. We can divide it by 90, which gives us 4. So therefore, the circle is now 4-dimensional.
Yeah, but the circle itself is a projection. If you what you see, suppose I see that.
What's it projecting on? It could be a sphere.
Like a sphere. You look at the sphere head on,
which
you see as a circle.
4 pi is its surface area. But yeah, well, okay. I think you need to be careful about what you mean by dimensions. You know, I'm not. I like what you're saying. It's very creative. I just don't think it's correct. from the strict
idea of dimension is that
string theory is also not correct. So don't bother.
Well, I'm not the one. I'm not like pushing string theory and saying it's correct. I'm just
the mathematical aspects are brilliant, but this is over provisioning of necessity of gear. So you have a lot of degrees of freedom in string theory, and it is good because you can flow and play with your ideas when you're good in math. But when the universe is simple, then you don't need all these gear. When the universe should be not simple, then you might need all these gear. And then it's justified to have a lot of mathematical freedom to express yourself. But I think that the universe is the most simple thing you can think of. And it will consist of Lego in subspace, when I'm right with these assumptions, which are independent cells of each other. So what I not expressed well is that all these three-dimensional boxes of Rubik's cubes are independent of each other. They are not in the same 3D space. They are independent Calabi-Yau spaces. And when you move them to the same position, say to 1, 1, 1 as a coordinate, then it depends what's in the box, if that is allowed or not. When light is in the box, then is energy in the box of the light you try to move through space-time, then it is allowed that these coordinates of two light boxes are at the same 1, 1, 1 coordinate, because they are bosons. They are allowed to, light rays can cross each other without interfering. Yeah. Gravity can cross each other without interfering. Gravity is bosonic.
They must all exist in the same 3D space.
But matter is not. Matter is not allowed to take the same position. When there is a matter box at position 1, 1, 1, then another matter box cannot be at the same position.
Yeah, we know that, but how does your model? So in one model they're in separate spaces, and the other model they're in the same space. Is that it?
No, this is what you put in the box. This is a geometric thing.
Okay. Yeah, okay, that's interesting.
Yeah.
But also, well, I would say that your description earlier of 6-dimensional space, where you have two boxes that are in separate trees. You know, you had
X, Y. For visualization. This is not what I mean that the space is two TVs. Okay, so this was just that you.
I know, but I'm taking.
The problem
I'm
is
taking
people
it
say I cannot envision. How do you visualize more than 3 dimensions?
Hang on, can I just finish the point I was trying to make? So you have the box, and then you have the box in another space. But still, both are three-dimensional. They're just separate instances of the box.
Yes.
So there's.
Say that, yeah.
But they're not like, there's still 3 dimensions and 3 dimensions. There's
no, because when the right box with 3 dimension has a specific content and moves to the position X of the left box, it can be at the same position and they don't interfere.
Well, that's
but
a different thing, though, because it wouldn't be exactly the same position. It would be X dash or whatever.
It would be because in 10-dimensional space you have 3-dimensional coordinates.
Also, you have to remember that if you have a 6-dimensional space, those 3 extra dimensions have to be orthogonal to all the other dimensions and to each other. So that's not true if you just duplicate the space and have a second space.
I give you a last. I really have to leave, but allow me 2 minutes. A last thought experiment that you understand the cell model. When you have a normal sea, where a submarine could travel through, say.
Oh yeah, I was actually going to pick a. I thought your submarine thing earlier didn't make a lot of sense to me.
No. When a submarine travels through water, it needs to press the water molecules away to pass the water, and it gets a maximum submarine speed. How do you accelerate a submarine inside water to much higher speeds than the actual submarine speed? And most physicists will say this is not possible, but it is super easily possible, and here's how. You take motors and machines on the right of a channel on the bottom of the floor of the sea, and one shovel rotates right and one shovel rotates left, and you make every 2 or 3 meter a pedal shovel rotating to the right and to the left, creating a water canal which flows between the row of symmetric shovels in the direction and accelerates physically, mechanically in the water molecule sea the atoms in one direction, pulling slower molecule random distributed in. The distribution of the flow inside the water pipe is easy to understand, is very, very fast because it's accelerated like a natural pump without a physical tube where the molecules move. They are still open in water, but when I make rotational cells in a narrow distance on the seafloor for a kilometer length, you have at the kilometer length moving water molecules at the speed of your rotation at the edge of your accelerators. You understand what I mean? It should be simple to understand.
No, I'm not following you.
Thousands of propellers, 500 propellers left, rotating leftwise, 500 propellers rightwise, and they accelerate water between them with nothing and water, all underwater.
So
when
you are
the
saying that
submarine comes to that virtual tunnel, it will be able to flow with 10 times the speed it would flow normally, because it will swim with the accelerated speed of the water molecules. We would just take in a high-speed river. But the high-speed river is just a distortion of the standard molecule situation when there are no propellers accelerating the water molecules.
All right, well, it's interesting. I haven't heard of anything like that before, but I'd like to see it.
Don't take it too serious, it's just a model, but this is easy to understand. When you have propellers and propel water molecules circular-wise, they start accelerating to the speed of the propellers between the propellers, naturally. They will do. Very simple to understand.
Yeah, maybe just, I don't know. I don't understand.
You have propellers and they have electricity, and the force of the electricity rotates the motor, and the motor rotates the propellers, and the propellers pushes the water molecules between the propeller row, and the propeller row, say, is 1 kilometer long. Yeah.
So are you saying that it creates a space in the water so that it can move through that space?
It's not space created. It is molecules moved with a higher speed than normally water would be allowed by drag.
It's like a stream. It's
So
like
when you have a car and you accelerate the car, then you need squared more force when you get to higher speeds, because the speed
So you are saying that
of drag of wind is not linear, and the same is underwater.
Well,
so
so
you are saying that
the car is accelerating, but it's accelerating the air around it along with it. But then that air is going to...
Yeah, the car is accelerating the air, but it has a finite speed. It cannot, even if it has fuel, accelerate more, because the wind drag will stop the car's acceleration at some 200 kilometers per hour.
So,
and that's it.
You didn't listen to what I said. I said the car is moving at some speed, and then it's taking the air with it, so it doesn't experience the drag. But the air in front of the air that's being taken with it will experience the drag. Will that not have an effect on the car?
Yeah, this is relative. The drag is at the front of the chain of the car, and when you put a submarine below water, it's the same.
Yeah, I know.
On the submarine, the drag is not just on the front. Every molecule flowing around turbulent on the side of the submarine will drag the ship slower, and you have to work against the pressure.
So Christian, what you're saying is that it creates like a stream.
It creates a stream, yeah, and the stream flow, the speed of the stream is not relevant what the submarine wants to do. The speed of the stream is only dictated by the rotational vortices of your propellers, and when
you can
when the propellers have enough energy, you can accelerate an extremely high speed, probably a couple of 100 kilometers per minute or so, per hour. And you come with a slow submarine into that stream, and shoo, it's accelerated instantly to the speed between the propellers, because the stream between the propellers is energy-wise supplied by electricity to run the motors. There is no perpetuum mobile effect or anything. It's just
an analogy. Come up with an analogy.
I understand more now what you're saying. It's okay.
Come up with an analogy.
Okay, I have to leave, guys.
See you later.
Just 1 minute.
Oh, sure. Rajan, what do you want?
1 minute. Okay. So suppose a car is sitting on a conveyor belt, right? And
yes.
And then the car can move on the conveyor belt. The conveyor belt itself moves.
Yes.
In the direction of the car, so you get more velocity altogether.
Presumably, yes.
Yeah. So it's something similar.
Just saying, like it, yeah.
I sent an email. I will try to answer better ideas about my model, and I have to excuse myself for that I wasn't well prepared, so I had no good answers to your question in a way which was easy to understand.
Have a think about the model that I was talking about and see how it applies to your work. Okay, see you later. See you, Rajan.
See you. Thank you. Next week. Yeah.
Okay.
Have a nice week.